Hey guys, and welcome back to the final paper 2 predicted paper. So this is option number C. So again, I have 3 different kind of variants for what I think the paper will look like. This is the third one. All the other 2 are obviously already recorded, uploaded on the channel, so you can check those out. If you want access to these papers, then use the link in the description to join the Discord. They're all uploaded on there, including the paper 3s, which are going to be uploaded soon. If you're unable to access that, feel free to email me and I will email you back with the papers in a zip file. But without further ado, let's just jump straight into it. So the first question, we have just a bunch of inequalities. So solving 7n is less than 3n plus 16. So basically you can treat this as if you were solving this, okay? You do the exact same steps. So the first step would be to subtract 3n from both sides, because you want all the n's on one side, which gives you 4n less than 16. And again, if you imagine that it was an equal sign, what would you do? You'd divide both sides by 4. So in this case, you're dividing both sides by 4. And you get n is less than 4, which is the 100% correct answer. Okay? Treat it exactly the same. The only difference is that with inequalities, if you ever divide or times by a negative, you would flip the direction of the inequality. Other than that, it's the same as just having equals. On the number line below, show the set of values for which minus 8 is less than 2x minus 2 is less than or equal to 4. So what we need to do is essentially rearrange for x. So you want x by itself in the middle. Now how does this work? Well, I would add 2 to both sides, right? But if you notice, I actually have 3 sides, so I actually need to add this to all 3 components, okay? So some people like to separate this into 2 separate inequalities, like rearrange them and then smash them back together, but you can just do it all at once. So add 2 to everything, which would give me minus 6, less than 2x, less than 6, divide all by 2, again, all 3 components, and that will give you minus 3, less than x, less than 3. So now what I would do is I would put a circle at minus 3 and 3. Then I decide if it needs to be coloured in or not. So since it's not equal to, I do not colour in the circles. And then all I need to do is draw a roughly straight line joining the 2 together. Pretty standard percentage profit question. So Jack buys a 24 pack of toilet rolls for £2.50 and he sells each roll for 25p each. Work out his percentage profit. So percentage profit, loss and change are all actually the same formula. What you're going to do to work out this percentage is you're going to take the amount he sold it for, so the sale price, minus the amount he paid for it, over the paid times 100. And this would be the same for percentage loss and also just percentage profit and change all at once, right? You're taking the difference in the amount of money like that he paid or sold for it, over the amount he paid times 100. So in this case, we need to work out how much he sold it for. Well, it's 24 toilet rolls for 25p. So if I put that in pounds, because the original price is in pounds up here, I will get, so just a quarter of that, which is £6. So the percentage profit is equal to the amount he sold it for, so £6 minus £2.50 over £2.50 times 100. Okay, so let's just work that out. Again, we have calculators, so we can do this. 6 minus 2.5 over 2.5 equals times 100. 140% profit. Not bad. And then to one decimal place, you just technically have to put a decimal point on the end. So yeah, that is all you need to do. That shouldn't be too bad. This here is a pretty good ratio question. So we've gone through ratios quite a bit on the channel. I even had that grade 3 to grade 9 ratios kind of video that we did earlier. And this was one of the types that comes up, which somewhat rare. So it says John, Mark and Susan share counters in the ratio. So we're going to write John, that's the wrong way around, Mark, Susan as 3 to 5 to 4. Okay? And it says Mark got 12 more counters than John. Well, if I have a look at this, that's these 2 people. And Mark got 12 more counters. He has 2 more parts than John, right? Like if I look at the difference in numbers, there's 2 parts difference between John and Mark. So those 2 parts must be worth 12 counters. Which means 1 part is just worth 6 counters. Right? Logically speaking. Now it's asking me for the total number of counters that they shared. Well, if 1 part is 6 counters, how many parts are there in total? Well, 3 plus 5 gives me 8, plus 4 gives me 12. So in total, there are 12 parts, and each part is worth 6 counters, so 12 times 6, which gives you 72 counters in total. Here we have a probability question. So Jack flips a coin 10 times and gets heads 6 times. Sarah flips a coin 100 times and gets tails 56 times. Will Sarah or Jack's results provide a more accurate estimate for the probability of getting heads? Give a reason for your answer. Well, the only variable here, the only thing that affects accurate or reliable or whatever when it comes to probability, the only thing is the number of times you do it. Okay? So in this case, it doesn't matter that Sarah flipped and got tails this many times. It doesn't matter. It doesn't matter about the heads or either. He could have, in this case, Sarah could have got tails 100 times, and hers is going to be more reliable because she did it more times. Okay? It's the most critical thing. Whenever you're dealing with probability, the more you do it, the more reliable or accurate your probability is going to be. No matter what, even if the data looks really weird. Okay? So, if they ever ask you how they can improve the estimate, all you have to do is say, do more trials. So in this case, Sarah, which is 1 mark, assuming you give an answer, you can't just guess, obviously, because she flipped the coin more times. Right? The other way you can word this is that there was a greater number of trials. Whatever you want, okay? Just, she did it more. That's the kind of idea here, okay? Using both Jack and Sarah's data, find an estimate for throwing 2 heads in a row. So what we need to do for that is we need to work out the probability of getting heads, right? And it says using both of their data. Now that's quite lucky for us. So all we need to do is work out the number of times they got heads over the number of times they threw it. Okay? So how many times did they get heads? Well, Jack got heads 6 times. Now Sarah got tails 56 times, which means she's got heads 100 minus 56 times, so 44 times. Of course, 44 times. So 6 plus 44. That's the total number of times they got heads, right? How many times did they do it in total? Well, Jack did it 10 times, and Sarah did it 100 times. So your answer is just going to be 50 over 110, okay? So actually, no, I'm just going to type it in fully just so you guys are, just to be fully transparent. 5 over 11 or 50 over 110. Right? That's not our answer. It's what's the probability or an estimate for throwing heads twice in a row. So we need to then times it by itself. Okay? Which, by the way, is the same as squaring. So if you just put answer squared, that'll give you your answer. 25 over 121. So for this question, we have to draw a linear graph, okay? So nothing too complicated. However, I did notice that some people aren't thinking with their calculators, okay? So with this, you can actually make your life a lot easier by writing this equation, but instead of x, just putting these numbers. So if we start with minus 2, here's what I'm going to do. 3 minus 2 minus 6. Now all I need to do is I now have my coordinates, minus 2 and 12. So let's do that. Minus 2, 12. Right there. Why is the pen? There we are. Okay. And then do the same thing, but this time we're just going to increase by 1. So minus 1. Minus 9. See? And that's all you need to do in order to work it out. And you can just keep repeating over and over again. And of course, I've shown you tricks before. For example, that the number in front of the x is what the y coordinates are going up in. So you can just, you know, you can basically just see what the actual trend is going to be. Just like this. And that'll be 6, and then 5 is going to be 9. And then obviously draw a straight line going through those points. Okay, but I just wanted to show you that trick on the calculator because a few People weren't using that when I noticed when I was teaching the lessons. They didn't know that you could just use your calculator and just quickly do it. You don't need to draw the plotting table if you don't need to, you know. Question 6, we have a vector proof or vector geometry question. So, CDEF is a quadrilateral, CD is equal to B, DE is equal to A, so we should probably start labeling these up just so we have them available. DE is equal to A. That's because I labelled it the wrong thing, that was obvious. Is B. And F to C, which is this one up here, so we should remember that this is D to E, which is going down this way, is B minus A. And we want to find F to E in terms of A and or B, giving your answer in its simplest form. Well, here's the thing with vectors. So the first step is always to label the vectors they give you if they haven't labelled them for you, because you want to know where everything is, what direction it is, etc. The next rule is that I can't just go straight from F to E, right? Because I have no vectors that go directly from F to E. So you can only go along vectors that you actually have the value of, right? You actually own, okay? So in this case, what we're going to have to do to work out what F to E is we're going to have to go from F to C, from C to D, and then from D to E. So the second rule now, so the first rule is you can only go along vectors you know or you can work out. The second rule is that if you go in the same direction as these vectors, as you can see I am, it's positive, you just add them as usual. However, if you go in the opposite direction, you need to flip the sign of the vector. You need to make it negative. So in this case, it's literally just B minus A, that's this vector here, plus B, which is this vector up here, plus A. So then that cancels out that, and then we're just left with 2B, just like that, okay? So I'm going to get rid of those red lines because they're not going to be relevant for the next part. Here's the juicy bit, the 4 marks over here. M is the midpoint of DE, X is on the point on FM, such that Fx to Xm is n to 1, and Cxe is a straight line, work out the value of n. So, here's what I would do. Again, they only give you information that you actually have to use, right? They don't give you extra information for no reason, right? So, we're going to use this information first. So, what it's saying is that Fx is going to be some fraction of Fm, right? That's what that n is. It's going to be the fraction of Fm that it is. So because we don't know what that fraction is, I'm going to call it k, right? Now this isn't necessarily going to equal n, okay? But we're going to use it to work out n. So again, all I've written here is that f to x is a fraction of the total line f to m. Okay? The next part is that cxe is a straight line. And we're going to do the exact same thing. So cx is some fraction, and we can call this maybe, let's say, y, of CE. Okay. So that's what those two things mean. And now all I'm going to do, I know this might look a bit scary at the moment, but all I'm going to do now is I'm going to write out equations for fx and fm. So how do I get from f to x? Well, we have f to x already. We can't actually work out a value. But we can work out f to m. Because f to m is just going to be f to c, so b minus a. So I'm going to write out fx here. B minus a. Plus the b on top. And then half of a, because don't forget it's the midpoint. That's what the midpoint means, right? It's halfway along. So b. So in other words, it equals k. B plus b says 2b minus a half a. So if I expand these brackets, I'm going to put the a, actually I'm going to keep the a second. That's my equation for fx. Now that's not particularly useful because I don't know what any of this stuff is, right? I have a bunch of unknowns. So now we're going to work out an expression for cx and ce. Now ce, that's actually not too bad. There's a couple of ways to do this. C to E is just going to be B plus A, right? So that just equals Y, B plus A. just like that. Cx is a bit more complicated because we don't actually know how we're going to get there. But what we could do is we could literally just have minus this vector, so go down this way, and then plus f of x, and we know what f of x is already. So that's exactly what I'm going to do. So I'm going to say that Cx is minus of this vector and then plus f of x. So now if I look at this, I actually have two equations for fx, which means I can do simultaneous equations. So I'm going to expand both sides and set them equal to each other. Let's write the y first, actually. I'm going to move everything that isn't f of x onto the other side. So I'm going to put the b's together, so that'd be yb plus b. And then it'd be ya minus a, right? Because we're going to minus a from both sides. Now, because we have two equations for f of x, I can actually sub this into here. Okay? That's exactly what I'm going to do. I have 2kb, so these are both equal to each other, minus a half ka equals yb plus b. Now here's where things get a bit interesting, okay? What I do is, this is all just algebra, right? So what we're saying is if we collect the like terms on this side, it should give me exactly this. So in other words, these two b's should simplify to give me 2kb. So what we call this is, we call this comparing coefficients. And this does come back in A-level maths, in case any of you are interested. But if I look at the a's, what do I have in front of the a on the left-hand side? I have minus a half k. So I'm just going to write minus a half k. And what do I have on the right-hand side in front of a? I have y and minus 1. If I do the same thing with b, on the left-hand side I just have 2k. And on the right-hand side I have y plus 1. Simultaneous equations, right? Because we have two equations with two unknowns. Now, what do I actually want? Well, I only care about k. I don't care about y, right? So if I subtract these two equations, that will give me my answer. So minus a half k minus 2 would be minus 2.5k, or minus 5 over 2k. Y minus y is 0. Minus 1 is minus 2. So if we rearrange this, well, the negatives will cancel out. Times by 2, we get 5k equals 4. So k is equal to 4 over 5. So now if I look back at the original question, right, or the original thing I wrote, f of x is 4/5 of f of m. So if I broke this up into a ratio, f of x is 4 and x to m is 1. In total, there's 5 parts, right? Because again, f of x takes up 4 parts, and x to m takes up 1 part. So it's 4/5 of the total line. So what is the ratio, n to 1? Well, simple. F of x to xm, if I write it from here, f of x is 4/5, right? To 1. So that's what n equals. And n can 100% be a fraction, okay? But yeah, that's all you would have to do for this question. So basically what this is, this is the ratio for f of x to f of m, right? But if I'm looking at just this part up here, in case you're wondering, if you're looking at this part up here, f of x is 4 and xm is 1, so the ratio is 4 to 1, so n is equal to 4. So what I just showed you is, if the actual question was f of x to f to m, then you would compare them like I just did. But in this case, don't forget, it says fx to xm, which is 4 to 1, because there's 4 parts for f of x and 1 part for f to m. For this question, we are given a sector, which is this overall pizza slice looking thing, and inside we have an equilateral triangle, and we have this shaded region as well. It tells us a bunch of information, so that it's an equilateral triangle for side 8 centimeters, so we can label that right now. All of these are 8, and there's actually something else we can label, but I'm going to get to that in 1 second. We need to calculate the area of the shaded region as a percentage of the area of the whole thing. So what we need is we need to work out the area of the shaded region, and we need to work out the area of the sector. Okay. Now, to work out the area of the shaded region, all we need to do is work out the area of this big sector, which, that's the other thing we need, so that's pretty useful, and then subtract the area of this equilateral triangle. Now, how do you work out the area of a sector? Well, a sector, I said it's a pizza slice, right? Which means it's a fraction of the total circle. So we're going to be using, area of a sector, it has something to do with pi r squared. It's a fraction of pi r squared, but how do we know what fraction it is? Well, all we do is we take the angle of the sector and divide it by 360. Now, what is the angle in an equilateral triangle? They're all 60 degrees. So in other words, this fraction here is going to be 60 degrees out of 360, which if you put in a calculator is actually 1 over 6. So it's a sixth pi r squared. So we can sub that in right now. However, do we know what the radius is? Well, the radius is 13, it's not 8, okay? So don't forget, it's the overall size here that we're interested in. So it's 13 squared. And again, we're just going to sub this into our calculator and ideally leave it as in terms of pi. So 13 squared, and then divided by 6, gives us 169 over 6 pi, right? And I want to leave it as a fraction because, in terms of pi, because then it gives my answer like a lot of precision, okay? So we've worked out the area of a sector, so we've already got some marks here. Now the shaded region, the way we're going to have to do this is work out the area of this triangle. Now, how do you work out the area of a triangle that is not a right angled triangle? Well, we normally use half AB sine C. However, if you split this in half and did all that fun stuff, you can do that as well. But half AB sine C is generally the way we want to go. A and B are just the two sides that make up the angle C. So we're going to use 8, 8 and sine 60. Okay. Again, you could split this in half and make it a nice two isosceles triangles. And actually, no, it wouldn't be isosceles, but two triangles and then work it out from there. So if you split this in half, the base would be 4, this side would be 8, so you have to work out the height and everything, but half AB sine C is far quicker. So, let's do it. A half, whoops, AB, so that's 8, 8, and then sine 60, just like that. 16 root 3, perfect. So it's given us in surd form, which I like, because again it's precise. So, the shaded region, again, if I look at this sector is this entire area here. So if I were to highlight it, it's all of this area. It's everything inside here. Okay? Absolutely everything. Okay? So in order to work out the area of the shaded bit, I need to get rid of the area of this triangle, right? So the shaded area, so I'm going to write area shaded, is just the area of the sector, 169 over 6. Wrote the wrong way around, 169 over 6 pi, subtract 16 root 3, which gives us an answer of, so I'm going to use the A and S button for 16 root, actually you know what, I'll write it out fully. 169 over 6 pi minus 16 square root 3 gives us that decimal. I'm going to do it to 2 decimal places. We don't need to be super precise. It does say just to give it to 1 decimal place. So maybe we'll do it to 3 decimal places then, just to make sure it's all Gucci. 775. So let's read the question one more time. We have all of the pieces of the puzzle, right? So we have 4 marks so far. We need the very last bit, which is calculate the area of the shaded region as a percentage of the sector. So the way you take a kind of make a number as a percentage of another number is you take the first number, so the shaded region, which is 60.775, and you divide it by the second number. So if they say write number A as a percentage of number B, you do A over B. So in this case, the shaded region over the sector, and the sector was 169 over 6 pi. And then you just times by 100. That's it. So let's do, again we're going to use the answer button for the long decimal that we had, over, and then we're going to have a little fraction, 169 over 6. I'm not 100% sure why it's not responding. 169. There we are. And then we're going to change that to pi. Yep. Press equals, times by 100. And again, to one decimal place is what the answer says, so 68.7. Again, make sure you read every single line in the question, because it's very easy to make a small mistake and not give it to the correct number of decimal places and just drop a mark for no reason at all. But that is how you do that question. This should hopefully be one of your favourite questions. All you have to do is type this in your calculator, write everything on your calculator display, and you get 2 marks. Super nice. Sometimes they even add a part B where you just have to round it. Super, super nice question. And again, it does come up fairly frequently. So again, just type it in exactly as you see it. If it doesn't look the same way as it looks here, then you've probably done something wrong, okay? But also read it very carefully. It may be easy, but if you make a mistake, you lose both marks. So it's kind of tragic, right? So after I've typed it in, I want to check it. So square root 3.68, square root 3.68, 0.74 to the power 4, cool, cos 60, right? Just do a double check. We have to write down all of those values. It's a lot of values, but look, it's 2 marks, okay, for writing down something on a calculator. It's not that bad. 9, 8, 3, 1, 8, 1. Also, make sure your handwriting's relatively neat. I mean, I know my handwriting is pretty terrible, but the numbers are all legible because they can drop marks for that, right? So just be super careful. So again, just as a kind of note for this question, this ruler that I have, it only goes up in degrees, so I can't be super precise. But keep in mind, they always give you a range of values. The reason why I'm saying this before is because you should hopefully know the structure of a scatter graph question, right? There's always going to be a question where it says, well, in this case, they're going to give you a shoe size, or they'll give you a height, and you have to work out the other. So someone has a shoe size of 7, what's their height? Someone has a height of 190, what's their shoe size? They always do this every single scatter graph question, okay? So in this case, it shows their height and their shoe size, but it's, weirdly enough, shoe size is on the y-axis. Again, there's nothing wrong with that, but just be aware of it. And it says, what type of correlation does it show? So, here's how you can check. You don't have to do this now, but you generally have to do it for part B anyway, so you might as well. If you get your ruler and try and draw a line of best fit, that's not bad. That's not a bad line of best fit. Maybe it needs to be slightly higher. Something maybe like that. And again, you want to do it so it ends and begins like in the right place. So in this case, our data starts at 150 and ends at 190. So that's what I've got there. Actually, no, it doesn't. My bad. I saw that part. Yeah. Like that. And if the line is going up, then it's positive correlation. If it's going down, it's negative correlation. If it's going horizontally, there's no correlation. That's it. So in this case, it's positive. You can just write positive, but just to be safe, I tend to write positive correlation because I'm a very paranoid human being. So a person has a height of 175, find their, or estimate their shoe size. So 175, this goes up in twos, right? Between 100, so it'd be 172, 4, 5. So what we're going to do is draw a dotted line going all the way up until we touch our line of best fit. This is what I mean by you had to do the line of best fit at some point anyway. And as you can see, it's going to be, well, this goes up in 0.5. Actually, no, it goes up in 0.4s. So 2, yeah, so 6.4, 6.8, 7.2. So it's 7.6, which technically you can get fractional shoe sizes, right? I know people that are like 2.5 or whatever. But you can easily get with saying this is a size 8 shoe. So you can write 7.6, which is roughly a size 8 shoe. Or you could write 7.5. Again, they do give you a range of values for that one. Next, we have some indices, which is something they enjoy doing because you can't use a calculator for it. So it usually comes up on calculator papers. So it says y to the power of 6 over y to the x is equal to y to the 7. Find the value of y. So that should definitely be x. That is a typo. That should definitely be x. Well, I'm going to have to go back and fix that. Well, that's good. Well, for those of you that have already done it, I'm going to leave that mistake in the video just so you can see that it was meant to be x. But yeah. So the way I would do this is I'd write down like exactly how you would simplify this. So when you divide two values, you subtract the powers. So we have y to the power of 6 minus x equals y to the power of 7. Now these indices should have the same value, right? Because they're equal. So in other words, we have 6 minus x equals 7. Move the x over to the other side. So we get 6 equals 7 plus x. So all I've done is plus x to both sides. Minus 7 from both sides, and minus 1 is equal to x. So x should equal minus 1. Okay? This one simplify. Well, when you have a power to the power of something, so whenever you have brackets, you multiply the powers. So that'd just be 3 to the power of 2 times 8, 16. Cool. So it can be written as 3 to the power of z. Show that z equals. So here's what you need to do. All they're doing is they're combining these two indices. But you might say, but they have different bases. Well, if you look at the answer, it's base 3. So what we're going to do is we're going to rewrite 9 and 81 in terms of 3. Now 9, in terms of base 3, is the same as writing 3 squared. And 81 is the same as having 3 to the power of 4. Okay? Sub that in, so we have 3 squared to the power of x is equal to, sorry, not equal to, multiplied by 3, 4 to the power of y. So expand this now. So again, we multiply when there's a power to the power. So we have 3 to the power of 2x times 3 to the power of 4y. When you times two things, what happens? You add the powers. So it's 3 to the power of 2x plus 4y, which is the same as 3 to the power of z, because remember it's saying show that z equals 2x plus 4y. So hopefully not too bad in that regard. And here we have an algebraic fractions question, and what we have to do is show that this thing simplifies to this thing where a, b, c and d are integers. Okay, so here's what you would do. The first thing I would do is actually do the keep flip change, right? Because it's a division in this case. So 6x squared plus 11x plus 3. So keep the first one the same, flip the second one, so it's now 9x squared minus 1 over 1. That is a minus 1, believe me, and that's a times now. So, now what do we do? Well, what you want to do is factorize any quadratics you have, because in virtually every single case, there's going to be some cancelling that you can do. So let's first factorize 9x squared minus 1. Now, if you have a look, this is a difference of two squares. This first thing can be square rooted, it's a square number. And 1 can also be square rooted. So all you want to do is you do two brackets. What's square root of 9x squared? It'll be 3x. Square root of 1 is 1, so we have 3x plus 1, 3x minus 1. That's how you factorize that. Cool. So instead of 9x squared minus 1 on the next line, I'm going to put 3x plus 1, 3x minus 1. So let's actually fill that in now. It's plus 1, 3x minus 1 over 1. Cool. Now we need to factorize 6x squared plus 11x plus 3. There's a bunch of different ways to do this, but I'm going to show you the somewhat rigorous way. So this is a way that you can do it very mathematically. I know some of you out there, you've probably gotten quite good at factorizing. You can probably look at this and see what you need to factorize as. Really good. That's a great skill to have, saves a lot of time. But I'm going to show you the longer method, but it will get you there. So the first thing you do is, because there is a number in front of x squared, it's not just x squared. So if there's a minus or any value in front of x squared, then you have to times this number by the n number, which gives me 18. So you're looking for two numbers that multiply up to 18, but also add to 11. So here you would just start listing out all of the factors of 18. So you can say like 2 and 9, 18 and 1, etc. 3 and 6. And then if I look at these pairs of numbers, do any of them add to give 11? Well, actually, these two. So we have 9 and 2. I'm going to write this exact same thing again, but instead of 11x, I'm going to replace it with 9 and 2. So that gives us 6x squared plus 9x plus 2x plus 3. And if you notice, this here, 9x plus 2x, would give me 11x. So I haven't actually changed the value of the quadratic. That's the key thing. At any step along here, you should be able to simplify back to the original thing that you had. Then we cut this in half. And I factorise the first two things out. What's the biggest number I can take out of 6 and 9? The biggest times table they both appear in. That's the 3 times table, so I'm going to factorise out of 3. X squared and x, so you take the lowest power of x, so in this case it's just x. 3 times what gives me 6? 2. I have x, but I want x squared, so I need another x, so I'm going to put x there. Then plus 3 times what gives me 9? That's 3. And I have x, and I want x, so I don't need to do anything else. Now the biggest thing I take out of 2 and 3, that's just 1. So keep in mind, you do have to take something out. That's why you put the plus 1 anyway, okay? You have to take something out. 1 times what gives me 2? 2. I need an x, so x. 1 times what gives me 3? 3. If you've done it right, these two brackets should always be the same. If they're not the same, go back a step and see if you can factorize something else out, because you've made a mistake. Everything in front of the bracket, so the 3x and the plus 1, goes into one bracket. And the duplicate bracket is your second bracket. So now we can continue with this. We have 1 over 3x plus 1, 3x minus 1. No, 2x plus 3 even. I can read, I promise. Multiplied by all of this. In fact, I'm going to move this down slightly because it looks a bit wonky. Like that. Now what we're going to do is something called cross-cancelling. Okay? So if you have the same term across from each other, you can cancel. So these 1 and 1s would cancel, but when you cancel 1, you just get 1 anyway. But here I have a 3x plus 1 and here I have a 3x plus 1. So I can cancel it out. Now I just do the multiplication. 1 times 3x minus 1 just gives me 3x minus 1. 2x plus 3 times 1 just gives me 2x plus 3. That's my final answer. If you have a look, a, b, c and d are integers. All of these numbers are integers as well. Okay. So depending on how quickly you can factorize, you can do this a lot faster. But again, I wanted to walk through it nice and slow just so you can visually see what happens with it. Here we have a conditional probability question. I want to preface this by saying that in most recent exam papers, they split conditional probability into two parts, an A and a B. A is generally where you're going to be doing some kind of probability tree or something, okay? So, but it is possible for them to actually combine A and B. So instead of saying draw a probability tree diagram, they could give you this information and jump straight to this for 6 marks or 5 marks, okay? That is something they can do. But in general, when you have conditional probability, right, you should use a probability tree diagram. You don't have to. And you guys have seen me do it without a probability tree, but it's a very easy way of visualizing it. How do I know it's conditional probability? Because this is a condition. If it's raining, the probability he wears a stripy tie is this. If it's not raining, the probability is different, which means it's based on a condition, right? And that should hopefully make sense, right? Like, let's say, what's the probability of you going out with an umbrella tomorrow? Well, you'd probably say, well, what's the probability it's going to rain, right? If it's raining, then I'll take an umbrella. If it's not raining, I'm not going to take one, right? So it depends. It's a condition. So we have to draw a probability tree diagram for this. So a teacher wears one of 2 ties, a stripy or a spotted one. If it's raining, the probability he takes a stripy tie is 0.65. If it's sunny, he wears a spotted one 0.4 times. Okay? It's equally likely for it to be sunny or raining. Draw a probability tree diagram. Okay, here's what you do. The first probability, right, is the condition. So if it's raining or sunny. So that's your first tree. Is if it's raining or sunny. So let's put raining on top because you know it's the UK. Okay. Now it says it's equally likely, which means they're both 0.5. And remember, across the branches should add to 1. So these two should add to 1, which they do. Then let's start with the first. So we've actually used this information. I like to tick off the information as I use it just to make sure I've used all 3 bits. If I haven't, then I've probably done something wrong. If it's raining, so we're going to do the raining branch first. So let's split it into 2 because there's 2 options, right? Here's a stripy and a spotted tie. So let's put stripy on top and spotted on the bottom. The probability he wears a stripy one is 0.65. So let's put the 0.65 here. And remember what I said, across the branches should add to 1. So all you're going to do, and I'll do it on a calculator just to make it a bit clearer, is you're going to do 1 minus this probability. Whoops. 0.35. because again, across the branch should add to 1. If you ever want to double check, 0.65 plus 0.35 does indeed give me 1. So that's all done, that's good. Then again we have stripy and spotted. If it's sunny, the probability where's a spotted tie is 0.4. So again, we're going to do 1 minus 0.4, which you could do in your head, but you know, it's calculator exam, why not use it? 0.6, okay? Perfect. So how does the marking work with probability trees? Well, it's a bit different than other kind of questions, okay? It works similar to Venn diagrams. Essentially, you start off with 3 marks, and you lose a mark for every number that's misplaced or incorrect. So if I got this probability wrong, or I didn't even include the beginning bit or something like that, I would lose marks, okay? So you effectively start with 3 marks and then you whittle your way down. So you have up to 3 mistakes. And that includes things like maybe not having this first branch, or like it being wrong or something like that, okay? It then says, on a given day, what is the probability wears a striped tie? So again, this is where probability trees are really, really useful. So let's look at the 2 different ways he can get striped tie, right? Well, it could either be sunny and he wears a striped tie, or it could be raining and he wears a striped tie. So did you notice how I said or in that sentence? When you say or in probability, it means you add. So first of all, what's the probability it's sunny and then he wears a stripy tie? Well, there's a 50% chance it's sunny, so we have 0.5, and he's wearing a stripy tie. So you multiply, because I said the word and, okay? So sunny and stripy, 0.5 times 0.6. Then the word or, that just means add, okay? Because there's 2 possibilities, right? It's either sunny and it's stripy, or it's raining and it's stripy. What's the probability if it's raining? Well, it's 0.5. And he's wearing a stripy tie, 0.65. Because again, we're going along the top branch. Then you just add those together. So you can do it all on one line on a calculator. Nice and, well, I'm not going to say it's nice and easy, but just be really rigorous with it. Draw everything out, and also take your time. I know that in an exam, you're in a high stress situation. It's very difficult to be relaxed. But I promise you, if you are relaxed in your exam, you will make far fewer mistakes. After paper 1, a lot of students have come up to me and said, I made mistakes, I made stupid mistakes. Because after the exam, you're no longer stressed. And you go, oh, yeah, I shouldn't have done that. So if you aren't stressed in the exam, you won't make those mistakes, right? Because you're already low stress. Hopefully that makes sense. Again, obviously, just calm down, lol, is not exactly it's not exactly a good piece of advice. So I'd recommend, you know, meditating, reasoning with yourself that once you're in an exam, panicking is pointless because you're there now. There's no point worrying, is there? You can't do anything else to fix it. But, you know, that's just me because I'm a bit weird. So if it's raining today, what is the probability he wears a spotted tie? So it doesn't say if it's raining. It says it's raining today. What is the probability? So the it's raining today, we don't need to include this first set of probabilities because it's telling me already. There's a 100% chance it's raining today because I'm literally looking outside, it's raining. What is the probability he wears a spotted tie? That would just be 0.35. Right? It's raining today. Probability of spotted tie is 0.35. Perfect. And this is something that a lot of students get wrong with things like probability trees, Venn diagrams, two-way tables, right? If they give you the condition, you don't need to include it in your probability, right? Like, for example, it might be one of the men is chosen at random. What's the probability that they're above the age of 21? You don't need to include the women. It's already given that it's a man, right? But again, that's all you need to do. So here they give us a triangle ABC, so we should probably sketch this out. Again, especially with geometry, I would always sketch it out regardless. Just draw like a generic triangle. It doesn't need to be accurate, bear in mind. It just needs to be, you know, a triangle. Did that just undo itself? That's a perfectly straight line as well. Interesting. I have no idea how that happened. But anyways, and let's label the points. So A, B, and C, and it tells me AB is 8.5 centimeters. BC is 5.3 centimeters, and BAC, this angle, is 30 degrees, and we need to work out the area of the triangle. Now, how do you work out area of a triangle? Well, if it's a generic triangle, you always use half AB sine C. And in terms of the letters, all it means is A and B are two sides and C is the angle between them. So in this case, if I had this angle, I could work out the area because I have two sides and the angle between them. Or I can work out this side and then I'd have two sides and the angle between them, which is actually the intention here. We're going to be using the sine rule to work out this side here, okay? Because we can't really use anything else to work out the angle. Working out the angle will take a bit too long, right? You can eventually, but why make it more difficult for yourself? So in terms of the sine rule, what is the sine rule? Well, the sine rule actually states that... So by the way, the sine rule, we can use that to work out this angle here, and then we can work out that. That's what I meant. I just realised it might be slightly unclear what I said. But we need to do two steps. So what we're going to do is use the sine rule in order to work out this missing angle. Because the way the sine rule works is you have a side and its opposite angle, and you have either another side or another angle, and you want to work out its opposite. So in this case, we have another side and we want its angle. Then we can do 180 minus both angles to get this. Okay? So, let's get started. The sine rule looks like this. There's two different versions of it. One of them looks like this, and the other one looks like this. And which one do you want to use? Well, it's quite simple. You can use either any time you like, but this one is easier because there's less rearranging if you're working out an angle. The bottom one is good if you're working out a side. But again, you can use either one, it's totally fine. So let's use the top one though. So in this case, A is 30 degrees, so we're going to do sine 30 over the opposite side, which is 5.3, is equal to sine, let's call it C, because it's the angle over here that I don't know yet, over 8.5. So sine C, all we're going to do is multiply both sides by 8.5, which gives us sine 30 over 5.3 times 8.5. And then we're just going to work out C straight away. So we have sine 30. And again, bear in mind with this question, again, there are quite a few different steps. You can even use the cosine rule if you really want to. But I don't know a lot of people that like the cosine rule, so we're going to do it this way. And then we're going to inverse sine it, because again, it's an angle. 53.31 degrees, let's call it. Let's call it 53.3. So then the angle at B is just going to be 180 minus those two angles. Let's do it. 180 minus 30 minus answer gives me 96.7 degrees, let's call it. Okay, so now we have both of these. And so I'm now going to use the area formula to work using this side, and this angle to work out the area. Is equal to half 8.5 5.3 sine 96.7. And I know some of you are probably looking at part B right now and thinking, okay, that's a weird question. And it is. It's very nuanced indeed. What the hell just happened? Did I press delete accidentally? Okay, whoops. 8.5. Yeah, I must press delete. Okay, sine, and then answer again because I'm lazy. 1.6, actually, is that correct? Oh, hold on. 96.7. Good thing I didn't use the answer button then. 22.4 centimeters squared. And it says 3 significant figures, hence why I gave it to that. 4-mark question. It's not the worst thing. Again, I was trying to show you exactly how I would think about the question as I was going through it. So when I'll draw it out 100%. When I have this little test group of students that I give this paper to. When they did this, they just subbed these values straight into here. Right? And if I read it, I think, yeah, that might be the case. But when I drew it out, I saw that that's not the case at all. That's the wrong angle. So again, I would draw it personally. I then knew I had to use this formula because it's an area, right? So you have to use that formula. And I then worked out, okay, so what do I need? Well, I can either work out this side or I can work out this angle. Now, this side would involve cosine rule and a lot of kind of jumbling about. It would require too much effort. So instead I was going to use the sine rule to work out this angle and then do 180 minus it, right? So I'm trying to show you my thought process on how to do the question. Write down what you need to use for the answer and then work out how to get those bits, okay? Now, part B, very, very interesting question, very strange. So if you did not know that it's an acute angle, what effect would this have on your calculation of the area? So, it says assuming that it's an acute angle. And the reason for this is the half AB sine C formula has to have a acute angle. So half AB sine C requires an acute angle. It requires it. Okay? If you try and do it with the one that's above it, you will get an answer, but it'll be very odd. Okay? So what would you need to do? Well, what you would need to do is find a different angle. So you would need to find, or you would need to use a different angle. Okay? That's what you'd have to do. Okay? So just keep that in mind. Everything that we use here, it generally gives us acute angles. So if you guys are interested in A-level maths, sine cosine rule comes up again, and guess what? You have obtuse angles now, and you need to do some stuff with 180, like 180 minus it, and all this kind of fun stuff. But for now, that's all you need to know. It's not on your spec specifically, but a question like this has come up before, which I think is a bit naughty, but whatever. With this question, it is a sketch, so you do not need to plot it exactly, okay? So one thing I was going to say is I was going to use this as an opportunity to once again show off how you can just type this whole thing into a calculator. If it said plot, right, you could type the whole equation in here, sorry, alpha, right, and then basically get all the values if you wanted to. But again, this is a sketch, which is slightly different. Then all you do is this, start from whatever, so we could do it from -7 to +7, steps of 1, boom, there you go. You can plot all of your values now. Easy, right? But in this case, we are not going to be using that. Instead, what we're going to be doing is sketching. So what do you need for a sketch? There are 3 things, right? And that's why you get 3 marks. They're looking for 1, the shape. It's a positive quadratic, which means it's going to be a U shape, happy face. 2, the y-intercepts. And 3, the x-intercepts. So y-intercept, how do you get that? Well, the y-intercept is when x equals 0. So all you need to do is sub in x equals 0 into the equation. And again, we can use our calculators if you'd like, or some of you may have already seen, it's just going to give you the number on the end, -4. But, you know, just for the sake of, you know, being super rigorous, let's type it all out. -4. Okay? Because again, when you intercept the y-axis, your x-coordinate is 0. So let's put a mark at 4 right now. Again, that gives you a mark. So shape, y-intercept, cool, we've got 2 marks, it's pretty good. X-intercept's a bit more tricky. Essentially, you need to make y equals to 0. So you're trying to solve this. Now, there are 2 ways. One of them, of course, is factorization. But, and this is something that I really want to hammer home, the quadratic formula is so much quicker in this case. It's so much faster. In fact, you can solve quadratics on your calculator automatically. But for those of you that may have a different calculator, we're just going to use the classic quadratic formula. Okay? Maybe I'll do a video on how to solve quadratics using this calculator just normally. And it will give you the coordinates that you need. And again, please make sure you use freaking brackets, okay? I've seen so many students not use brackets, and then they get the wrong answer, and they go, oh, I was meant to use brackets. And I go, I did tell you, again. That's my first x-intercept. It's at x equals 2. So all of this I've just done on a calculator, nice and easy. And minus 2/3. So let's put that over here. And what I want to do as well, by the way, is I'm actually going to label that as minus 2/3, 0. Then we're just connecting that with not a straight line, but a curve, okay? So it's quite a squished one, but that's okay. All we're going to do is do something like, let's do it. Like that. So we've got the shape, we've got the two x intercepts, and we've got the y intercept, we're done. Okay, you do the whole thing on a calculator, nice and quick, nice and easy. Again, the shape doesn't need to be a work of art, thankfully, otherwise I'd have failed my GCSEs. But that's all you need. And again, you can do it all on a calculator. Really quick, really easy, okay? This question, expanding triple brackets. So, I mean, my poison is that we just pick two brackets, expand those, and then expand the third. So, for the sake of, I don't know, ease, I guess, I'm going to expand the first two brackets. So 2x times x is 2x squared. And again, I can expand this a lot quicker. I can expand and simplify in one step. I'm going to do it in two separate steps, but if you expand and simplify in one step, perfectly good for you. So 2x times x, then 2x times minus 6, so minus 12x. 1 times x, so plus x. 1 times minus 6, minus 6. Easy peasy lemon squeezy. Then we're going to simplify, so we have 2x squared, just as per normal. Then we have minus 12x plus x, that's minus 11x now. And then minus 6. X plus 4. So now we've got two brackets again, we're going to expand two brackets. Now the key thing to remember here is you're going to get 6 terms in total if you don't simplify in one go, obviously. Because you need to times this first value by both of these terms, so that's 2. This value by both of these terms, that's 4. This term by both of these values, that's 6, okay? So first of all, 2x squared times x. In fact, maybe I'm going to try and do this. 2x squared times x gives me 2x cubed. 2x times 4, 2x squared times 4 is going to give me 2 times 4 is 8, and then x squared. Then we have minus 11x times x, which gives me minus 11x squared. Then we have minus 11x times 4, which is minus 44x. And then lastly, but certainly not least, we have minus 6 times x, minus 6x. And then minus 6 times 4, which is minus 24. Now we need to simplify. Although this question doesn't actually specify simplify, which is, you'd probably be in your rights to not simplify it, but just in case in the actual exam they ask you to simplify, which they 99% of the time they will, we have 2x cubed, right? And I like to actually put a light cross over the ones that I've done. Now, because I'm actually going to hand this out, what I'm going to do is I'm going to just put a little cross on top. Then we have 8x squared minus 11x squared, so that'd be minus 3x squared. So we've done those two. Then we have minus 44x minus 6x, that's minus 50x. And then just minus 24 in the end. It's not hard, but it's very easy to make a mistake. So be really rigorous, write everything out nice and neatly. Try and not simplify in one go as well. Like, do it nice and separately. Make sure, and then check it after each step, right? So like how I said, you should have 6 values once you expand these two brackets. I have 6 values. And here we are with some sequences. I love sequences, they're pretty good. I'm going to show you a very quick and easy way to do it. I've shown 2 methods how to do kind of arithmetic sequences. So they give you some terms, you need to work out an expression for the nth term. One of them was using the A-level formula, where D is just the difference, and A is just the first term, so in this case minus 2, right? However, I want to show you another way of doing it, just to give some variety. So the first thing you're going to do is you're going to work out the difference, and the way you do that is you quite literally just take this term, subtract this term, so that'd be plus 10. 18 minus 8, plus 10. 28 minus 18, plus 10. And you're going to write that number and put an n afterwards. Then what you're going to do is you're going to go to the first term and you're going to go backwards. So if I was going backwards, what would the term before minus 2 be? Well, I would subtract 10, right? So that would be minus 12. And then I just write that number here. There you go, done. That's probably the fastest way I've ever seen that you can do it. So just work out the difference going that way, then go back one, nice and easy, okay? And for part B, where it says the nth term of a different sequence is 6n minus 4, is 128 a term of the sequence, show how you get your answer. All you need to do is you write the nth term and you make it equal to 128. And you're going to solve for n. So let's add 4 to both sides. We get 6n equals 132. Divide both sides by 6. And what we're looking for here is whether or not it's a whole number or not. I should say a positive whole number as well, just to be clear. 22. So, because it's a whole number, it is part of the sequence. And the way you'd kind of justify that is you say, yes, it's the, in this case, 22nd term. Okay? If it's negative, you obviously can't have a negative, right? Because that's like, I mean, how does that work? The first term, then second term, what would be the negative term, right? It'd be before, it doesn't make sense. And if it's a fraction where you can't have the 1/2th term, right? The half term, like, that doesn't even make sense. So in this case, just solve it. So make it equal to the nth term formula. Solve it for the unknown, for n. If it's a positive whole number, it is part of the sequence. You just write, yes, it's the 22nd term, 5th term, whatever, okay? Other than that, it's going to be a no. Now we have some 3D trig, everyone's least favourite, awful topic. So you get given this massive cuboid. AB is 9, so let's add this information. AB will be the same as DC, so let's add that information as well. CH is 12, so we have 12. And that would be 12 for all of these vertical heights here, of course. AD and BC aren't necessarily the same, by the way, because it's a cuboid, so the lengths can be different. And it says angle BCA is 46. We'll use that in a second, but let's think. We need to work out the size of the angle between DG and the plane. So this line here, interesting. So what we're going to do is we're going to write out, I'm going to draw out a little triangle. And this is the triangle we want. So we want, this is DG and the plane, so that would be B over here. So this would be theta, right? And BG we know is 12 centimeters, because again the height is all 12. Do I know anything else? DB, I don't know. DG, I don't know either. So let's move on. Let's look at this information here, BCA. So that is BCA. It's like a triangle on the bottom of this. So if I draw the base out quickly, we have A, B, C, D. So this is like we're looking at it straight down, right? And what we have is the angle, so AB is 9 centimeters and also DC is 9. But with the angle, that would be, so if it's BCA, it's going to be this angle here. Now, here's something interesting. If you notice, we have DB here, right? Which is this diagonal. Now, the diagonals of a rectangle are the same length. So in other words, AC is going to be the same as DB. So now you might be, well, actually I don't know why I wrote that. If I write the actual angle here, 46 degrees, I can actually work out what AC is. And then use that to work out DB. It's going to be the same. So that's exactly how I would approach this question, right? Draw out all the information and then see what you can use. So I can work out AC by using trigonometry. This is the opposite angle, that is the hypotenuse, and this is the adjacent. So we have SOHCAHTOA. And what that's going to give is, we need O and H, so that's so. So we have sine 46 equals O over H. The opposite is 9, although it looks like 90 now that I put the O there, so let's get rid of that quickly. Over AC. So AC times both sides by AC and then divide by sine 46. You get 9 over sine 46. So 9 over sine 46. We get 12.5, let's call it. Which again is the exact same as dB here, which is 12.5 centimeters. So now we can just use tan, because this is the opposite side, that's the adjacent, that's the hypotenuse. So we have tan theta is equal to opposite over adjacent, so 12 over 12.5. So it means theta is going to give me inverse tan 12 over 12.5. And I'm actually going to use the full form by using the good old-fashioned answer button. 43.8 degrees for that question. So yeah, hopefully not too bad. Hopefully. But yeah, that's exactly what you get. This question, we have a histogram which shows information about the ages of 72 members at a gym. And it says 70% of the members of the gym under 30 years old are male, and we need to work out an estimate for the number of male members who are under 30 years old. So wording is a bit tricky, but if we have a think about it, what it's basically asking us to do is find out how many people are below 30 years old and then take 70% of that number. So how do you work out how many people are under 30 years old? Well, what you do is you go to your histogram, and what you're going to do is find where 30 is, which would be about here. You're going to draw a dotted line going all the way up, and what we're essentially going to do is all the way to the top. And what we're going to do is, since we're looking for under 30 years old, we're basically working out the area of the graph that's under 30 years old. So all of this, okay? Because remember, the area of a bar on a histogram gives you the number of people in that width. So in this case, we have a width of 20 and a frequency density of 1. So 20 times 1 gives me 20 people in this first box. And then here we have a difference of 10, and it goes up to 0.55. So that means it's 5.5. Now you might notice that you can't really have a decimal point of a human being, but if you notice, it does say work out an estimate. So with histograms, we don't actually know exactly how the distribution is within the classes, so you can expect to sometimes get weird kind of answers like this. So what we're going to do is, in total, we have 20 plus 5.5 equals 25.5 under 30-year-olds. So that's men and women. So now for men, what we're going to do is we're going to take 70% of that number. So 70% of means times 25.5. And then we're going to round to the nearest whole number to work out an estimate. So 70%, again, we can just type in 70, shift, answer, times 25.5, and you get 17.85 men. I would recommend writing out the decimal version first, but then saying that there's 18 men as a whole number. Okay? So here we have a circle theorem proof. It hasn't come up in recent memory, so it's likely to come up now. So we have the proof for the angle at the center being twice that at the circumference. A very classic proof, okay? So how do you do this? Well, from first inspection, if we just write that this angle here is, let's say, 2x and this is x, there isn't really, you might think, okay, it's a bit tricky in how to kind of figure out what the answer is. But if you notice, if we draw a straight line going from B to O, then all three of these sides are going to be radii, aren't they? They're going to be the radius of the circle because it's going from the center to the 3 points on the circumference. So what does that mean? Well, it means that these two triangles here are isosceles triangles. So what does that mean? Well, that means that these base angles here and here are going to be the same value. Should we call them, let's say, x? And it means that these angles here are also the same. Now, it doesn't mean that they're the same as each other just yet, right? They might be at the end, but we can't say that for sure right now, okay? So, okay, that's quite fascinating. So we have this. Well, that means we can work out the third angle in the triangle for both of these, right? So we've got these two sides. Well, what should we call that? Well, maybe something like W and Z, because we have then X, Y, Z, you know, W, X, Y, and Z. Makes sense. And W is just going to be 180 minus X and minus another X, right? So again, if we just look at this left-hand triangle, all three of these angles should add up to 180. So that means W is just going to be 180 minus the 2x. We can do the exact same thing with the other angle, Z. That's going to be 180 minus 2y. Interesting. Now, the angles that we want, we have one of the angles we want. And we want to now work out this other angle, right? Because remember, the proof is that BOC, this angle here, is 2 times this angle over here. So this angle BAC is just equal to x plus y. So now I want to work out an expression for BOC. Well, what would BOC be? Well, these will be 3 angles on a point, right? Around a point. So the angle BOC, and what do the angles on a point add up to? They add up to 360. So it'll equal 360 minus W minus Z. Now, if we sub in our equations for W and Z, we get 360 minus, we're going to use brackets because don't forget all of it's going to be negative, 180 minus 2x minus Z, which is 180 minus 2y. So this would be 360. Actually, I'm going to write it out super clearly. I'm just going to write the full thing out. So 360 minus 180 plus 2x. Don't forget, when you have a minus on the outside, it's going to flip the sign of everything inside. Because minus times 180, then minus 1 times minus 2x. Then minus 180, then plus 2y. And if I simplify this, the 360 will cancel with the 180 and 180, right? 360 minus 180 minus 180. And that gives me that BOC is equal to 2x plus 2y. Well, if you notice, BAC is x plus y. So I could write this as 2x plus y. Or in other words, I can write that as 2 times BAC. And that would be the proof. So what are the steps of the proof, just to make it super clear so you don't have to memorize that much? Well, you draw a line from O to A, and then you write out, in terms of algebra, how you'd work out the angles at the center. Okay, those are the 2 major steps. You can break it down into more steps if you'd like, but this would be kind of the working out. You don't need to go as in-depth as I have, but, you know, I like to do it nice and in-depth for you guys so you kind of get the best value out of this. With this question, I have a small confession to make. Essentially, when I exported the file, some of these lines got a bit jangled up. This line here should be going through point R, which changes some things. Because again, when I looked at this question, I was kind of checking the mark scheme and everything. I noticed a difference in the diagrams, and I thought, damn it. So what I'm going to do is I'm going to update the version in the Discord, but those of you that have access to it beforehand, you're probably going to notice a mistake. But essentially, this line from F to E should go through this point R here, okay? I'm very, very sorry for that. Again, I'll get that updated. Anyways, the point here is we're trying to prove that this angle at D is equal to this angle at F here, so DEF. Okay? So I'm going to label this one X just because I don't know what it is. And the purpose of this is because it's kind of inside a circle, what you're supposed to realize is that from O to the edge of this circle, that makes both of this the radius of a circle. So this thing on the right is an isosceles triangle, which means if I work out this angle, I instantly know this angle. Now, if this is X, if you have a look, DORF, that is a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral add up to 180. So that makes this 180 minus X. Okay? Now, this angle over here, well, that's just angles on a straight line add up to 180, right? So in other words, this angle here should also be X, because 180 minus X plus X gives me 180. So that means that must be X. And again, because it's an isosceles triangle, that means these two are the same. So obviously you need to actually write some words down. So you can simply say that if FDE was X, then FRO 180 minus X because of cyclic quadrilaterals. Then you can say that ORE therefore equals X because angles on a straight line. Will add up to 180. So again, 180 minus X, what do I add to get to 180? I add X, right? And then lastly, DEF equals X because of base angles in an isosceles triangle. And that brings us to the end of the paper 2 predicted papers. So again, paper 3 will be coming soon, but before then, I'm actually going to do some biology, chemistry and physics papers because those are coming before paper 3 maths. Well, the physics one isn't, but I'm going to do those as well.